Hello everyone, I'm Vivo Ken. Today I will give the presentation of our paper Audiovisual Class-Incremental Learning, which is proposed by Vigo Pian, Shengdu Mo, Yuhui Guo, and Yapeng Tian from UT Dallas and CMU. Okay, now let's start it. Firstly, I introduce what is class-incremental learning. This can be summarized in one sentence. Each task contains several classes and non-overlapping tasks arrive sequentially. And the testing data of each task is come from all same classes. It's an important field in deep learning and is challenging because of the catastrophic getting problem in it. That is the significant performance drop of all the tasks after training on new tasks. In our work, we firstly conduct experimental study on pure fine-tuning strategy with the modality of audio only, visual only, and audio visual. From this figure, we can see that the performance of using audio visual modalities can better handle the catastrophic gating problem. And using audio only or visual only modalities to train models in classroom learning settings are much easier to cause the gating problem. Therefore, in this work, we try to use the joint audiovisual modality to better solve the gating problem. However, there still has some challenges in audiovisual class-incremental learning. The first challenge is how to preserve the semantic similarities between audio and visual similarities modalities as incremental step increases. Since audio and visual semantic similarity may become dissimilar in previous classes after training on new classes. The second challenge is how to preserve the learned audiovisual correlations in audio-gated visual attention. Specifically, in this figure, the heat map in each frame shows the attentive level of different spatial regions by the corresponding audio, and the transparency of each frame demonstrates its temporal attentive level. We can see that the learned audiovisual attentive ability in previous tasks get vanished, which causes getting of learned audiovisual correlations in previous tasks. To address these changes, we proposed a new training approach for audiovisual class-incremental learning named ABCL. Our approach includes a base model architecture and some training constraints for incremental learning. The base model contains a visual encoder, audio encoder, audio-guided visual attention module, a fusion layer, and a classifier. The main contributions of our approach are the dual audiovisual similarity constraint and the visual attention distillation. The dual audio-visual similarity constraint aims to preserve the semantic similarities between audio and visual modalities, while the visual attention distillation is for preserving the learned attentive abilities in previous tasks, so that it can reduce the getting of learned audiovisual correlations in previous tasks. And we also add the task-wise knowledge distillation and the separateness of the max entropy in the training process. These two techniques comes from previous work SSAL. You can refer their paper for more details. In our experiments, we use three data sets: AVE, kinetic sounds, and the VG sounds, and select this 5 class-incremental learning methods as baselines. That's pure fine-tuning, learning without gating, SARL, SSIL, and the EFC. We evaluate the performance of our proposed ABCL and baselines on two most commonly used metrics: mean accuracy and the average of gating. Here is the mean experimental results. We can see that our ABCL outperforms all baselines on all three data sets significantly. This demonstrates the superiority of our proposed approach. We also show the visualization of the attention heat map after training with our ABCL. We can see that the both spatial and temporal attentive abilities can be preserved, which also shows the effectiveness of our proposed visual attention distribution constraints. That's all my presentation. Thank you for listening.